Section 2.7 is talking about solving equations with integers, and that's something that we've done several times over the course of our class so far, but it's something that I want to keep going back to and expanding our knowledge and understanding as we go. So I've pulled some snips from the book that I want to rely on and then also to talk about. Of course, the first part is that an equation is a statement that expresses two, or that it's a statement that two expressions are equal. The way that I think about this is if you have a set of balances or a scale, if you will, with weights attached, the implication is so long as you add the same thing to each side, so if you add something here and you add the same something here, they will maintain the balance. It will continue to be balanced. And an equation is the same way with the equal sign. So long as I do the same thing to both sides, I keep the equation balanced. The other bit that they talk about is that a solution of an equation is the number that makes the statement true. Uh, but what that really means for us in terms of doing the math is if I take the value that you give me as a solution, I should be able to put it in place of the variable, do the math, and come up with an answer that makes sense mathematically or that is true. And they also point out that a solution set is a set of all the solutions to an equation. But then they go on to talk about the fundamental fact or theorem of algebra, which is that every equation ax plus b equals c, which is the type that we're talking about right now, has exactly one solution. And I just want to bring your attention to that because it's something that we have talked around but not about yet. So in the form ax plus b equals c, we mean for A, B, and C to have values. Like there's some number that's given to us. And X is the variable. It's the part that we're trying to figure out. The fact that X is written without an exponent here means that I can assume the exponent value for X is 1. Remember that X to the first power is just X. And it's this value that tells us that the equation has exactly one solution. So at any time that we see an equation with a variable of degree 1, remember that means exponent is 1. It implies one solution. That's not particularly important to us at this point, but I'm pointing it out so that when we get further down the road that it won't be a completely new concept to us. And then the last bit here is we're given a set of steps that we can follow top to bottom that will get us to a solution regardless of the situation. So we can apply these rules 1, 2, 3, 4 to an equation sort of analogous to the way that we work with order of operation. So if I say x plus 9 equals 2, I can start trying to apply these rules to find a solution that works for this equation. All right, so I don't have any parentheses, so I don't need to distribute anything. Combining like terms on each side of the equation, remember that like terms are either constants or variables with the same degree. So here I don't have any like terms to combine. So then I move to the third step, which says if a constant is added to a variable, use the addition principle to add its opposite to both sides. We've talked about this in the past. We have a plus 9 that is being added to our x. If I want to do the opposite of adding 9, then I need to subtract 9. And remember the balance, if I want to maintain balance with the equation, then whatever I've done on the left side, the subtracting 9, I need to do that to the right side as well. Okay, so now I do so this is why I said it's analogous to order of operations. At each step, I then go back and see, okay, what order of operational or what number of solving an equation can I do? Well, now I can combine like terms. I know that plus 9 minus 9, that's just going to be plus 0. And that means that really I'm just left with x on the left-hand side. And then 2 minus 9, well, that's going to be negative or minus 7. And now effectively I'm done with this one. I look through and I say, okay, there's nothing on the side with x and there's no number out in front of x. I'm just left with x. And so my solution to this particular equation should be x equals negative 7. Remember I said that a statement's true and I could substitute in to check that. So if I perform a little check here and say, well, if I have x plus 9 equals 2, and I plug in x equals negative 7 to try, I get negative 7 plus 9 equals 2. And right, when I take 9 and subtract 7 from it, or take negative 7 and add 9 to it, either which way you want to look at it, I get 2 equals 2. And yes, indeed, that is a mathematically accurate statement. And realistically, I probably should have put, well, not there, should have put a plus sign before we did our addition, because at this point we don't know if they're equal or not. But now that we've checked it, we know that x equals negative 7 is the solution to the equation x plus 9 equals